classifying scalene, isosceles, and equilateral triangles by side lengths or angles. Okay, so we need to really quick review what do these mean. And I know we've reviewed these in a previous video, but if you don't have your notes, you should be taking notes. You should be keeping your notes. The more you write it down, the better. So if you have to write it down again, that's fine. It's not going to hurt you to write it down again, but you should definitely be keeping some notes here. All right, so scalene triangle means that no sides or no angles are equal. Are equal. So this is the basic definition. No sides, no angles are equal. And then we have isosceles triangle, and it's two, I'll put it this way, at least two sides or two angles are equal. I'm going to be a little lazy there, and I'm going to write that. So you can write equal. You know what? I'll go ahead and write out the word here. Oop. Equal. And it can be equal, congruent. I'm using the word equal here for whatever reason, but we want them to have the same measure. So we want to be the same size and shape, which actually means congruent, but it's all right. Either way, we'll still get the same results here. And then we have equilateral triangle. So this means all sides and all angles are equal. Because they might give it to us either way. So if a shape is equilateral, it actually means equal is equilateral to sides. So this is specifically talking about the sides. So all sides are equal. But if all the sides of a triangle are equal, all the angles are also equal. So this is another relationship we've talked about in previous videos. If a triangle is equilateral, it is also equiangular. If it's equiangular, it's also equilateral. They're kind of interchangeable there when we're talking about triangles. So we're not going to get all the angles and all the sides in one. They're either going to show us that all the sides are equal, or they're going to show us that all the angles are equal. So they'll give us one or the other on that one. And then we just get to go and classify. So if we look at this one, we have 5, 7, 11, and we're looking at the sides. Well, the only one where all the sides, no sides or no angles are equal is scalene. So we click scalene. Triangle B, we have 7, 7, and 7. So all the sides are equal. We know that it's equilateral. This is where it comes a little tricky. Isosceles says at least two sides or two angles. So at least two sides are equal, so we would also click isosceles. So if you click equilateral, immediately click isosceles because they both work. For this one, so this one's giving you isosceles. It's giving you two congruent angles. And this one said at least two sides or angles. So I have 45 and 45, so I know it is isosceles. And then down here I have 45, 60, and 75, all different angles. So we go to scalene here because no sides or no angles are equal. So this is where we'll go. And I just noticed I forgot my E on angles, and for whatever reason that's bugging me. So I'm actually going to change this word to or. So all sides or all angles are equal because they're not going to give us both. It's not going to be an and. It's going to be an or. All right, so let's go ahead and click start and go ahead and do this one. So triangle A, I see 7, 7, and 7. This is the exact example they just gave us. So if all the sides are equal, I know it's equilateral. If it's equilateral, I'm going to immediately click isosceles because isosceles, the definition is just at least two sides. So at least two sides are congruent, it's isosceles. All right, this is another one. This is the exact example they just gave us. So we have two angles that are congruent. And remember, isosceles means at least two sides or two angles. So I know it's isosceles. All different lengths for the sides here. So if it's all different lengths for the sides or all different angles, it's scalene. And then triangle D, I have all the angles that are equal. So remember, it was all sides or all angles equal. We know it's equilateral. As soon as I click that button, I want to click isosceles. And we're going to check it. All right, two more. So this one, triangle A, we have 45 and 45. So we have at least two angles that are congruent. So we know it's an isosceles. Triangle B, 60, 60, 60. All the angles are congruent. So I know it's equilateral. As soon as I click that, I also want to click isosceles because at least two of them are congruent. And that's all that I need to classify it as isosceles. All right, everything's different on this one for the side lengths. So that is a scalene. And then all the lengths are the same for triangle D. So that means that it is equilateral. Again, as soon as I click that one, boop, I want to click that one too. Because again, isosceles requires only two. Equilateral has three. So 3 is at least 2. Okay, one more. We have triangle A, so all the angles are congruent again, which makes it equilateral, and I immediately click isosceles. And then here we have 30, 60, this is the 90 mark. So these are all different angles. So if we have all different side lengths or all different angles, we call that a scalene. Triangle C, we have 4, 7, 10. So we just talked about that. All different side lengths, scalene. Triangle D, we have 4, 8, and 8. At least two sides are equal. We call that isosceles. Check. And we finish another one.